Hi, my name is Dana Golden. Now we're going to pick up with the second lecture in Environmental and Natural Resources Economics, and this one will be on externalities in the market. So we're going to get started with a little bit of a rehash of last time, just a very quick focus on supply and demand, and then how that comes into environmental economics. So just a reminder, the supply curve, you have a quantity supplied, and then you have some function of price, production inputs, technology, expectation about future prices, and number of producers and external factors. So over time in any economics class, and especially in environmental, the goal is to go from equations that are relatively simple and relatively concrete to equations that are more and more complex and account for more and more variables. We're not necessarily more complex, but complex in different ways. And here again, we have our old friend, the price elasticity of supply, which is the responsiveness of supply to price changes. This is really how the market, how you determine how the market's going to respond to policy. And then you also have demand. Demand is a function of the price of the good, consumer income, price of substitutes, price of complements, consumer taste and preferences, expectation, number of buyers. So you have all these factors that affect demand, all these factors that affect supply, and also one thing you should notice is price is in both. So price is a really important variable. In fact, it really, interesting enough, in this case, if you'll notice, price is in the function that determines demand rather than the other way around. So price really, even though it's an equilibrium object, really is the independent variable in economics. Really, prices determine quantities supplied and quantities demanded rather than the other way around. So it's kind of interesting that when you have this equilibrium, you have the supply and demand meeting, price is on the y-axis. Just a traditional economics thing, but remember, very importantly, that price is actually an independent variable. And then the price elasticity of demand, measures the responses to demand to price changes. When you have a demand elasticity greater than 1, you have a inelastic demand. You have an elastic demand that's relatively flat. You have a demand where a slight change in prices has a big effect on quantity demanded. If you have a demand that's less than 1, demand's not really responsive. If demand is less than 1, you won't have much of an effect of demand to taxes. Common demand format is the linear demand curve. So sample market equilibrium problem. You have a demand equation, you have a supply equation, and then like last time, you find the quantity demanded and the price equilibrium. We did this last time, but just to review, if you have these two objects, you set them equal to each other and you can solve for the Q star and P star because the quantity supplied equals the quantity demanded and the price is equal both in equilibrium. So now let's get on to something we did talk about last time, which is consumer and producer surplus. And this is probably not new to you either. You probably saw this in principles or applied micro. So consumer surplus is the difference between what consumers are willing to pay for a good service and what they actually pay. So it's the area under the curve of the demand between the price consumers pay and the price they're willing to pay. So if you take the demand curve here, and you have this demand curve, you go and integrate all the way down, and you get that area, and that should give you the consumer surplus. So that's the idea, is that if you're paying as much as you are willing to pay, you're not really getting a surplus. So really, surplus is price above what you're willing to pay. And then producer surplus is price times quantity minus the integral of the cost of producers of each quantity. So right here, if you'll remember, the supply curve is also the marginal cost curve. So you integrate this little triangle up to price, and you get the producer surplus. So producer surplus plus consumer surplus is the market's total surplus. And they're going to be very important objects in this particular class, as you'll see in a moment how they come into environmental. So consider a market for coffee where the demand curve is given by P of Q equals 100 minus 2Q, and the market price equals 40. So we first start with the consumer surplus, 100 minus 2Q equals 40, Q equals 30. So the consumer surplus is the area of the triangle on the demand curve. Remember, we have linear demand. Otherwise, we'd need to take an integral. I chose these example because I didn't want you to have to take an integral here. And then, so we are able to use a triangle. Q equals 0 is the start of the triangle. Q equals 30 is the end. So the base is 30. And then the height is 100 minus 40. 100 being the intercept with the y-axis, and 40 being the actual price. So consumer surplus equals 1/2 times base times height equals 1/2 times 30 times 100 minus 40 equals 60. So 1/2 times 30 is 15 times 60 is 900. The consumer surplus is 900. Now, same thing with producer surplus. We have a market price of 40. We solve for quantity. Quantity equals 30. The producer surplus is the area under the triangle because it's a linear supply curve. The form of producer surplus, once again, you have this integral, but you can just solve as a triangle. We're going to compute the integral today, though. So 40 times 30, price of the market times the quantity, minus, and then we have integrated this. So this was originally 10 plus Q. As this becomes 10Q plus Q squared over 2, 1200 minus 300 plus 450 equals 450. The consumer surplus equals 450, and so the total surplus is the sum of these two. 900 plus 450 equals 1350. Coase's theorem is an interesting point about equilibrium, and it's very important in environmental economics. It states that under certain conditions, private bargaining will result in efficient allocation of resources regardless of the initial property rights. So this is the idea that it's an interesting idea in economics, but basically the idea is that the problem of externalities, which we'll talk about in a moment, but the problem of externalities is that there aren't property rights and there aren't markets. There aren't transaction costs. So pollution is really a problem of not having a market for clean air. If you had a market for clean air, you could figure out how much everyone's willing to sell their clean air for, and you can figure out exactly how much to charge for pollution. The basic idea of Coase's theorem is that you can always find a trade to mitigate all the harms and find an efficient solution as long as there's a market, as long as there's low transaction costs. The problem is that often environmental property rights and don't really exist, and transaction costs are often quite high. So mathematical representation of Coase's theorem: let X represent the level of an externality and C of X be the cost of the affected party. The benefit to the polluter can be represented as B of X. An efficient outcome occurs when the marginal benefit equals the marginal cost. So B prime of X, the derivative of the benefit, is equal to C prime of X. If transaction costs are 0, the parties negotiate to maximize joint surplus. So this is basically the idea. If there's good property rights and if there's a market for everything, you can find a solution that works for both parties, and they can negotiate a way to maximize surplus by making sure that the optimal level of pollution happens and that the optimal outcome happens. Externalities are a problem of a missing market. The final level of X doesn't depend on the initial allocation of rights, but depends on achieving marginal costs using marginal benefits. So when we go through this externalities, this public goods section, I want you to think about, when you think about, like, why are there externalities? Why do these things happen? Think about what market is missing, what transaction cost is high, and why there aren't property rights for this thing. And that'll give you an intuition as to how externalities emerge. So the intuition behind Coase's theorem, the core idea is that property rights are clearly defined. Individuals can negotiate to reach a mutually beneficial solution. So consider two parties, a polluter and a harmed party. Without any intervention, the polluter has no incentive to reduce pollution. If you give property rights to either party, the two can bargain. They will exchange payments and figure out a solution that works for both of them. And the polluter will say, I'll give you this. And the other party will say, well, actually, that doesn't justify the solution you're putting out. And then eventually they'll come to a solution where everyone is happy. So through bargaining, resources are allocated until no further gains can be made. So the initial distribution of property rights only affects the distribution of wealth, not the level of pollution in the final outcome. This is an important thing to think about, is that as long as you have property rights, and the property rights are correctly given, externalities aren't really a problem. You're always going to end up with the correct distribution of pollution, or the correct distribution amount of the negative externality, because you've internalized the externality. And that's something I want you to really understand, is that this section of the course is going to be about how to internalize the externality, make the costs or the benefits clear to all parties. So let's talk about some assumptions behind Coase's theorem, even though we kind of mentioned them already. Low transaction costs. Bargain enforcement costs are negligible, allowing parties to negotiate freely. If it's really hard to negotiate a solution, it's not easy to set up a carbon market. It's not necessarily easy to figure out the amount of carbon dioxide you're creating. So it might be high transaction costs. There are clearly defined property rights. It's not clear who owns the world's fisheries or the world's oceans. Parties are assumed to act rationally. I'm not really that opposed to this assumption. We're not going to talk much about irrational agents, but one of the assumptions of Coase's theorem is that parties aren't irrational and don't try and spite each other. And where this really comes up is if parties negotiate in bad faith or aren't willing to accept offers that are really good for them. It's hard to define irrational behavior, but if it exists in the model, that would hurt Coase's theorem because of the assumption. There are no wealth effects, so the change of property rights doesn't affect preferences. And then perfect information. This is, I think, the most damaging assumption of Coase's theorem. Low transaction rights is pretty hard. Clearly defined property rights often doesn't exist for environmental goods. Perfect information is extremely difficult. There are many environmental markets where people just don't know the costs and benefits. And it's not always easy to say what the costs and benefits are, or the parties that will have them. So that's why we have a lot of this particular class. We have an entire class on imperfect information, because that leads to a lot of the market failures that are important in environmental economics. So Coase's theorem fails sometimes when not all participants can participate in markets. Our children cannot, animals cannot, and someone has to be there for the trees. Someone has to be the tree lawyer. And, the tree's not going to be there for themselves. And so if you say the tree should have rights, Coase's theorem's not going to work because the tree can't negotiate. Not everything can be divided. This is an interesting thing. Joseph Stiglitz made a comment about Coase's theorem and basically was like, his friend of his had been a big believer in Coase's theorem, and then two other friends of his were credited for a contribution that this friend made. And Stiglitz made the comment, why don't you just give this friend a bit of the Nobel? Why don't you just give them a bit of money and make them feel happy? That's the failure of Coase's theorem, and that's why war happens sometimes. Is because war is economically irrational, but the truth is you can't divide Jerusalem. You can't just give someone a little bit of a Nobel Prize because they were wronged it. Sometimes you really can't divide the thing, which makes it challenging to negotiate over. And it's very difficult to create some markets and evaluate fairness. It's really hard to know who was really harmed. We have an incredibly complex judicial system to deal with that problem. And then finally, a big part of environmental economics is going to be market failures. And normally in economics, especially because of Coase's theorem and a lot of the important work that was done in the 1950s, we assume that markets create optimal outcomes for society. This is especially important in the neoclassical framework where, you really start from ground zero with the idea that markets can do no wrong. But when this does not happen, the market has failed. A lot of people will be like, well, economics doesn't account for that. No, economics definitely accounts for that. And actually, economics, particularly neoclassical economics, has some really great solutions to that, which we'll talk about in this course. So market failure occurs when the assumptions of perfect competition are violated or markets are missing. So classic examples, monopoly violates the assumption of many players. Public goods, which we'll talk about later, violate the assumption alongside externalities that the benefits of a good only accrue to one individual. Incomplete information, which we'll also talk about in this class. So traditionally, market failure is judged by Pareto efficiency. So when we talk about market failure, we talk about the idea that there's someone we can make better off such that the total surplus is increased. If you increase the total surplus, you can redistribute the gain so that everyone benefits. If you have an increase in total surplus, then it's just a distribution problem at that point. Is this the right framework? Pareto efficiency says if one guy has all the money and everyone else has nothing, and you can make that one guy slightly worse off and make everyone else significantly better off, if it decreases overall overall wealth and overall surplus, that's not a good idea. Traditionally economists have not dealt a lot with distributional outcomes, but redistribution is hard. So there is a real case for supporting non-Pareto efficient outcomes, and the idea that market failures aren't necessarily the result, or that sometimes market failures are the case even in a Pareto efficient outcome because of distributional factors. So how does policy fix market failures? Economists are not always anti-government intervention. When there are market failures, economists champion these. So economists generally say this is a special case where governments have a role in fixing the market. Mandating information in the car market, taxes and subsidies, and externalities, and stopping collusion. Policy can also, interestingly enough, create a market failure. Policy can distort market incentives and have unintended consequences. Some taxes, market regulation, and regulatory capture have big effects on the choices of agents. A good example is the catalytic converter. With the original catalytic converter, one company patented this way to remove this pollutant that was created by cars. I believe it was sulfur dioxide, and then the catalytic converter removed that pollutant, and so it was mandated that every car have a catalytic converter, but several other car makers were very close to a clean engine. So just a reminder that you have to think about the effects before implementation, because policy has unforeseen and often dynamic impacts. We're going to leave it there. I hope you have a great day, and I'll see you next time when we talk about externalities.